Hello everyone, welcome back to our YouTube channel Let's Grow. I hope you are very well and doing great in your life. So today in this video we are going to discuss about the water hammer, its definition, causes of water hammer and various factors affecting the water hammer process. So let's begin this video without any further delay. So initially we will discuss with the term water hammer. So what is the definition of term water hammer? If water is flowing through a channel or a pipe and it is stopped abruptly, that means its momentum is broken, so a pressure surge or wave results. This effect produced is called water hammer or hammer blow. So in this figure you can see, when valve is closed position, water is still. If this valve is in closed position, the water will remain present in left of the side and right side will remain empty. When the valve is in open position, the water will flow continuously. But the moment when you close this valve suddenly, the momentum of water will be in the direction of right side. So basically in this second position, what is happening? Water is continuously flowing in this direction, correct? But when you close this valve suddenly, the water remain present here, has a momentum. So the momentum of water help to produce a wave which will move in the opposite direction with some higher velocity, which may cause the damage to the pipe in the upstream, correct? So this phenomena is called as a water hammer, and it is because of the sudden closure of a valve. And this term water hammer is also called as hammer blow. This effect can be produced in any fluid. When a flow is stopped, backwater effect is produced, in which a wave of water moves against the flowing water. So water was flowing in this direction, but when the moment you close the valve, a backwater effect will produce and a wave will start to travel in the opposite direction. This effect is called water hammer. Water hammering is caused by a pressure or a shock wave that travels through the pipes, generated by a sudden stop in the velocity of the water or a change in the direction of flow, correct? So the water or the wave which will travel opposite to the direction of flow, which will cause the water hammer, and it can also be due to the sudden change in the direction of flow. If the flow is changing, the direction of flow is changing suddenly, in that particular case also that this water hammer effect can be present, correct? It is due to the sudden closure of a valve or sudden change in the velocity of the water. If the pipe is suddenly closed at the outlet, the mass of water before the closure is still moving forward with the same velocity, building up a high pressure and a shock wave, correct? Because the water that is present over here is still have a momentum to flow, but you have obstructed the path by means of closing of valve. So that momentum or the energy or the shock will start to travel in the upstream direction. A common example of water hammer that takes place in most homes every day, the example is simply a turning off of a shower quickly will send a loud thud through the house. So if you are taking bath and you will close the valve of a shower suddenly, so you will listen as sound, thud sound, correct? So it is due to the effect of the water hammer. Water hammering phenomena can cause the failure of fitting or the bursting of pipe. So what are the negative effects of water hammer? It can cause the failure of your fittings, pipe fittings, or if the pipe material is not sufficient enough to take that pressure, then the bursting of pipe can also be happen. The water hammer can cause the pipe to break if the pressure is high enough. When a valve in a pipe is closed, the water downstream of the valve will attempt to continue flowing, creating a vacuum that may cause the pipe to collapse or implode. So right now we have seen the effect in the upstream side, but what about this another side in the downstream? So in this second figure, here water is flowing in the downstream direction, here water is present, correct? Here water is present, but when you close the valve, there is no water, or the water that is present will try to move in the downward direction, so it will create a vacuum, correct? It will create a vacuum which may cause the collapse or the bursting of pipe also. Because in the second figure, when valve is open, the water is present here, but when you close the valve and this present water will start to flow in the downstream direction, there is vacuum will produced in this particular length of pipe. So due to that vacuum, the pipe material, the pipe can be collapse or the bursting of pipe can be seen. Now talking about the investigations, that who was the first to investigate this water hammer phenomena. The first to successfully investigate the water hammer problem was the Italian engineer, and the name of that Italian engineer was Lorenzo Allievi. Which water hammer can be analyzed by two different approaches. So basically he has given two different approaches to analyze this water hammer effect. The rigid column theory, so which ignores the compressibility of the fluid and elasticity of the walls of the pipe, or by full analysis including elasticity. So there are two approaches to analyze this water hammer, but we are not going to discuss the approaches, but the basics about these two approaches are: the first approach suggests that the compressibility of fluid is ignored whenever there any fluid is present that is compressible up to some extent. So basically when you suddenly close the valve, the fluid present over here will compress, correct? Because there is a momentum of water which is forcing this water to travel in this direction, but you have obstructed the path. So due to compressibility of the fluid will compress. The another aspect is that the pipe material is elastic, so there are some strain will produce in the pipe. So the one theory, which is rigid column theory, this theory ignores both compressibility of the fluid and the elasticity of the valve. Means the fluid is treated as incompressible and the pipe materials are rigid. On the other hand, other theory suggests that the fluid is compressible and the elasticity of the pipe material can also be considered. Now the factors affecting the water hammers. Generally the sources that cause the water hammer are the pressure in pipe, velocity flow in pipe, and sudden change of velocity flow. So there are basically three terms or three parameters which affect the water hammer. First one is the pressure in the pipe, second one is the velocity of flow in the pipe, and third one is the change in velocity, correct? So the pressure, velocity and change in velocity control this water hammer effect, and obviously this velocity and the pressure are interrelated. If velocity is higher, pressure will become low. If pressure is higher, velocity will become lesser if the pipe is of uniform cross section. There are other sources that may affect the waveform predicted by classical water hammer theory, including viscoelastic behavior of the pipe wall material, blockage and leakage, in addition to the unsteady friction, cavitation and fluid structure interaction. What are the factors which affect the water hammer? First is the improperly sized piping in relation to water flow velocity. We have to consider the water flow velocity, and accordingly we have to determine the pressure, and we have to look at the pipes whether the pipe is able to sustain that particular pressure or not. So accordingly we can resize the pipe. High water pressure with no pressure reducing valve. If there are some chances of water hammering, a pressure reducing valve should be provided so that the additional pressure which is generated by this water hammer effect can be reduced. The straight runs that are too long without the bands. If the pipes are let down in a straight run which are very much long, then the water hammer effect will be too much severe. Correct? Why? Because the shock wave that will produced by the water hammer will travel a long length, and the effect on the pipe can be seen in the longer run. But on the other hand, if the pipe is having some bands, so due to the bands, the effect of that shock wave or the velocity of that shock wave will reduced. The poor strapping of piping system to structure. If there are some poor strapping, there are some higher chances to cracking of the pipe at that particular points. No dampening system in place to reduce or absorb the shock wave. Some damping system are need to be placed to absorb these shock waves to reduce the water hammer effect. So happy learnings with Let's Grow. I hope you like this video. If you really like this video, make sure you hit that like button and subscribe our channel.